Okay, so I'm going to go through the rest of the paper today, questions 12 to 22. So this next question, not many people, I don't think anyone actually got this one correct. So there's a couple of ways you can do this one. You could use single multipliers, or if you're not given an initial volume, or if there's talking about percentages and you're not given an original amount, you can always just make up the original. And if we choose 100, that's a really good number you can work with. So we don't know the volume of P, but we can give it a value. So we're going to say let's PP 100. So we need to increase that by 150%. So we need to find 150% and then add that on to the original. So we know 100% of 100 will be 100. We know 50% of 100 will be 50. So then if we add those two together, we know 150% of 100 would be 150. So we want to increase it by that number. So that means adding on that extra 150. So that means volume of Q would be 250. We can now do the same. So R is 50% more than Q. So we now need to find 50%, but this time 50% of 250. So we can just half that, and we're going to get 125. So then if we want to increase the amount by 125, we're just going to add that on. So that's going to give us 375. So that's what the volumes would be. Find the volume of P as a fraction of R. So that means you're going to take the volume of P and put it as a numerator over R as your denominator. So P is 100 and then R is 375. Now it doesn't say fully simplify your answer, so that would be fine to give that as your answer. If it was to say fully simplify, then we would need to divide them both by common factors. A common factor would be 5. So 5's into 100 would go 20 times, and we can divide this by 5 and we get 75. If you're not sure, use your long division or short division. And then common factor of both of these again would be 5, so divide them both by 5 and you get 4 over 50. There we go. Okay, next question 13. So we haven't done much proof. However, what you can do is to use some of your algebra knowledge to expand out this double bracket. Now lots of you did substitute numbers in, which is pretty good, and you found that whenever you put n in, you always got an odd number. Now that proves it for every case that you have shown, but it doesn't prove for every single case. So a few things about odd and even numbers. If you add together two even numbers, so an even number plus an even number, if you double any even number, you'll always get an even number. So even plus even will always be even. That's one thing to note. If you add an even number to an odd number, you always get an odd result. Okay, so that's two facts that we're going to need in a minute. So we need to prove that this will always get you an odd number. So first thing we can do is just expand that out and see what we get. So if we expand out, and you can all do this, n plus 1 squared. Now that means you've got n plus 1 times another n plus 1. You should be able to expand out that double bracket quite easily. You get an n squared, you get two n's, and you get the number 1. And we just want to add on an n squared to that. So if we now add on n squared to that, we're going to get 2n squareds plus 2n plus 1. Now there's a couple of ways you can do this one. You could factorise the first part, so then you would get 2, now fully factorised you'll get 2n on the outside, but when you're doing proof you don't actually need to fully factorise, but I will just say that we keep that skill up. So 2n on the outside and then n plus 1. And then plus 1 at the end. Now this part here is all being multiplied by 2. Any multiple of 2 is always even. So this here must be even. And the reason for that is it's a multiple of 2. And by definition, an even number is a multiple of 2. It's in your 2 times table. So this part here has to be even. And then you're adding on 1, and 1 is an odd number. So just by definition, that we know an even number plus an odd number always gives an odd number. There we go. Alternatively, you could have said that 2n squared is even, 2n is even, even plus even is always even, and then when you add that to an odd number, you always get an odd number. Right, question 14. You need to know your exact trig values, so there's a few ways you can learn them off by heart. There's a table, there's 14 to learn off by heart, or if you go on Maths Watch and put in the search bar exact trig values, they've got a really nice way of remembering them using a hand trick where they number your thumb and your 4 fingers with the numbers 0 all the way up to 90. So 0, 30, 45, 60 and 90 on each finger, and then there's a way of putting down fingers to work it out. So look on Maths Watch, if you just put in exact trig values, you can be shown that method, so you can do that as an extra. So exact trig values, if you put that into Maths Watch in the search bar, they've got a really nice way of learning them off by heart. Now there's another way that I tend to learn them off by heart, and that is using a equilateral triangle where all the sides are 2, and because it's an equilateral triangle, all the angles are 60. And then what I do, or it's not my method, but the method then tells us to find half of that by splitting it down the middle. This angle here is 60, and because you split it down the middle, that angle there is 30. This length here is still 2. Because you split the equilateral triangle half, the base there is 1, and then if you use Pythagoras to get this side, 2 squared minus 1 squared, 4 minus 1 is 3, so this is the square root of 3. So this is a triangle that I use to work out my exact trig values, and this will work for any 30 degree and 60 degree one. So tan 60, so if you look at 60 degrees here, the opposite will be your root 3, and your adjacent will be 1, because when we think about our tower triangle, we are using opposite and adjacent. So tan is opposite over adjacent. So this tan 60, because that angle is 60, is the opposite, which is root 3, over the adjacent, which is 1. So now we know tan 60 is root 3 over 1 is just root 3, so that's what tan 60 equals. We can use the same triangle to work out sine 30. Well, you might know that one already off by heart just because it comes up quite a lot. So that one there is 30, so that's the one that we're looking at. These lengths are still the same. And then if we think about our sine triangle, it's SO. So sine is opposite over hypotenuse. So sine 30, now we need to find the opposite and the hypotenuse. So the opposite there, which is 1, and the hypotenuse there, which is 2. So the opposite of 1 over the hypotenuse is 2. So sine 30 is 1/2. Now you do not have to show these in the exam. You just need to know them off by heart, which is ridiculous to be honest, but that's what they've asked you to do. So tan 60 times by sine 30. So let's just substitute those in what we've just found. So sine 60 is root 3, and you're timesing that by 1/2. So leave it in fraction form. So root 3 times 1/2 will be root 3 over 2. Right, this one here was actually done pretty well by most people. So for this I would do it in 2 separate parts, which most of you did do. Now you've got a cone on the top and then you've got a hemisphere on the bottom. I would first of all just work with a sphere and then half my answer. So I'm just going to draw a little cone here just so I know what I'm talking about. And I'm going to put the radius of the cone, which is 6, and the height of the cone, which is 20. So I'm just going to draw a little diagram there. And then I'm going to put the V for volume. So the volume equals, and then we're going to look up, now you will definitely get this formula in the exam, 1/3 times pi times the radius squared. So I'm going to substitute that in right from the start. So 6 times 6 is 36. and then times that by the height of 20. So your first job is just to pop the numbers into the formula, and you will definitely get the formula with the question for spheres and cones, only spheres and cones. Then we want to tidy this up before we do anything else. So the first thing I do is to check, well, I need to divide this all by 3. So I'm just going to check, can I divide any of these numbers by 3? Don't divide all the numbers by 3 because they've all been times together. If they've all been added and you were dividing it by 3, then you would have to divide them individually. But we just need to divide one of the numbers by 3. So I'm going to divide 36 by 3 because that's nice and easy to do. So a third of 36 is 12. And then we're going to times that by pi and then times that by 20. Just going to keep the same order to begin with, just so we don't get too confused. So 1/3 of 36 is 12. So 12 times pi times 20. Now what we can do is to times the numbers together and put that first. So 12 times 20, well, we can do 2 times 12 is 24, times that by 10, so 240 pi. Now you definitely have a lot more space, but I want to keep all this on here. So I'm going to just do some workings up here, but if I was to do it in my exam, I would do the next part underneath. I'm going to go over here. I'm then going to work with a sphere, first of all. So just going to draw a little diagram of the sphere there, and the radius is 6. And then again, like the other one, the volume is 4/3 times pi times, now I know 6 times 6 times 6 is 216. If you didn't know that, you might as well do a few calculations to the side. So we know 6 6 is a 36. We want to times that by another 6. So 6 6 is a 36. Carry the 3. 3 times 6 is 18. Add 3 is 21. So 216. Right, to tidy that up, we need to divide 216 by 3. And then we want to times that answer by 4. So again, I'm just going to do some calculations to the side, just so I don't muck up my workings over there. So I want to do 216 divided by 3, and then times my answer by 4. So 3's into 21 goes 7, 3's into 6 go twice, and then I want 4 lots of 72. So 72 times by 4, because it's 4/3. 2 times 4 is 8, and then 7 times 4 is 28. So that means the volume is 288 pi. However, it wasn't a sphere, it was a hemisphere. So all we need to do now is to work out the volume of the hemisphere. So we just need to divide the top answer here by 2, so 144 pi, because I divided that by 2. So once it in the answer k, so that's just a constant number, or a number times by pi. So we're going to add the 2 together. So 240 pi plus 144 pi. So our final answer is going to be 384 pi. Now on the dotted line is where I would put 384. So k, and you've got a lot more space there for more workings out, is 384. Okay, combination locks now. So we've got 3 dials, and we have the numbers 1 to 6 on each dial. So the way I do combinations is just to show the options basically. So I do a little blank there for the option for the first dial, and then option for the second dial, and then options for the third dial. So the options for the first dial, we know we could have numbers 1, 2, 3, 4, 5 or 6. So you're going to write in here how many different outcomes are available. So there's 6 different outcomes, so I'm going to put 6 as how many outcomes there are for the first one. You then multiply that by how many outcomes there are for the second dial. Well, that's also 1 to 6. And then for the third one, also 1 to 6. So 6 times 6 times 6. And I've already calculated that in the question before. Very handy. So I know that's 216. So for question B, I'm going to just do question B just here, just so we can keep all this on the screen. So again, we've got the 3 dials, and in each slot, I'm going to write the different combinations. So we need to have 3 different digits. Well, for the first digit, you have a free choice and you've got 6 different outcomes. So there's a choice of 6 dials for the first one, could be any number from 1 to 6. But there is a constraint now with the second dial, and that is you can't duplicate a number. So let's say the first dial is the number 1, you can't choose the number 1 for the second dial. So that means you've only got a choice of 5 different numbers. So there's a choice of 5 for the second lot. And then for the third dial, if you've chosen a 1 and then let's say you've chosen a 2, you now only have 4 different options for the last one. So you're just putting in these spaces here, your options, and then you multiply all those options together. So times them all together, 6 times 5, which is 30, 30 times 4, so 120 for that one. Okay, this is really, really tricky. I'm going to show you a couple of ways you can think about questions like this. So the first way of thinking is looking at your ratio, and this ratio basically says for every 1x squared, it's worth, sorry, not for every 1x squared, x squared is half basically of minus 2x plus 12, because this is twice the quantity of the first one. So to make these two quantities even, or not even, equal, you need to double the first quantity and then they will equal each other. So you need 2x squared to be equal to minus 2x plus 12. Now that's quite a nice ratio because it's just saying that the second one is double the amount of the first one. That's what that's saying. And if you make the first ratio part twice as big, they will then be equal. But these ratios in your exam might not be very nice, so there's another way to do this in case those numbers aren't very nice. And that is if you divide the first quantity by the first number in the ratio, it will equal the second quantity divided by the second number in the ratio. So if these numbers aren't very nice, you can just put them underneath, and then you just need to get rid of the denominator. So times both sides by 2, so that removes that 2 there, and you get 2x squared here. And then you want to times, so you're timesing basically this top part here by 2, and you're timesing this bit here by 1 to get rid of those denominators. And then timesing it by 1, you're just going to get the same, and then look, you can see you've got the same two answers there. So that's 2 different ways of forming an equation. So once you've formed your equation, you need to solve it. So let's just stick with the right hand one here, so there's a bit of space. So because it's a quadratic, I want to equal it to 0. So I'm going to keep my 2x squared on the left hand side. I'm going to add 2 x's, and then I'm going to minus 12, and that equals 0. Now very nicely, when you have a quadratic with all even numbers, you can half the whole lot, because it equals 0, and half of 0 is still 0. So half the whole lot and equal that still to 0. Because it's a non-calculated paper, it's most likely going to factorise. So 2 numbers now, let's do some calculations over here, that times together to give minus 6 and add together to give 1. So our options are going to be 6 and 1, 2 and 3, and one of the numbers needs to be a negative. So what we're thinking is, okay, so which of these numbers, take away the other number, gets you 1? Well, 6 minus 1 is 5. 1 minus 6 is minus 5, so it's not that one. 2 minus 3 is minus 1. 3 minus 2, well, that gets us 1, doesn't it? 3 minus 2. So 3 minus 2 must be the answer. So x minus 2, x plus 3. And then remembering to get these brackets equaling 0, it's, well, what must x be to make this bracket 0? Well, x must be 2. And to make this bracket 0, well, x must be minus 3. So there you go, there's your 2 solutions. Okay, next question, number 18. This was done pretty well. So we only need to actually work with root 18 because root 2 is already sorted into its simplest form. So two numbers that multiply together to give 18 would be 9 times 2. So root 9 times root 2. Always put the square number first. The square root of 9 is 3. And we're doing root 9 times root 2. Keep root 2 as it is. Now I'm going to bring down this root 2 here, because actually we've got we've got root 2 plus 3 root 2. So 1 lot of root 2 and 3 lots of root 2. I'm going to pop the answer over here, is 4 lots of root 2. Okay, this next question, if you get this in the exam, one similar to this, just play around with it and see if you can work with it. So it's saying we've got 9 of these being multiplied by each other. So I'm just going to write out what that actually means. We've got 1 lot of root 2 times, now this is quite a long way to do it, however you'll see how we can calculate this answer. Well, there's 4 of them. Let's keep on going. 5, 6, 7, 8, 9. So we've got 9 there. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if you multiply these two first fractions together, multiply the top numbers. 1 times 1, the numerator is 1. And then if you've got a root 2 times a root 2, root 2 times root 2 is root 4, and the square root of 4 is 2. So that gets you a half. So that means for each of these, they're going to be a half. And we've got 4 of those. So let's just deal with this bit here first. We've got a half times a half times a half times a half. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So that part equals 1 over 16. And then we're timesing that by another root 1 over root 2. So what we now have is 1 over 16 times by 1 over root 2. So that's going to get us 1 over 16 root 2. Now, we can't actually leave square roots on the bottom. It's just what we call not rationalised. So to rationalise the denominator, we're going to times the top and bottom of this fraction by root 2. So 1 times root 2 is root 2, so that's the top. Now let's think carefully about this. Let's go do some calculations to the side. We've got 16 root 2, and we want to times that by another root 2. We'll just look at the root 2's to begin with. Root 2 times root 2 is root 4, and root 4 is 2. So that means we've got 16 lots of 2, which gets 32. So 32 is the denominator. Right, this one is one that lots of you actually can do. It just doesn't sound like what we've done before, but this is actually a completing the square exercise. So we need to force this into a squared bracket, and to do that we divide this number here that sits in front of x by 2. So that's going to be a minus 4 squared. Now the reason we do that is because you get most of this sorted in this first part. X times x is x squared, which is what we wanted. You half it because you have a minus 4x's over here, and then a minus 4x's here. When you add a minus 4x and a minus 4x, you end up with minus 8x, which is exactly what we wanted. So far, we've got x squared minus 8x, but the problem is minus 4 times minus 4 is a plus 16, so we end up with plus 16. Now, ignoring that little one at the moment, I like to do this in 2 separate parts. What we're looking for is factorising the x squared minus 8x part. Now, they don't actually equal themselves at the moment, because if we expand this out, we actually get an extra 16. So in order to make it equal, I need to remove that 16. So if I have a minus 16 here, they are now equal because I've taken off that 16. So that means x minus 4 squared minus 16 gives us this first bit here. And then if you just drop down the plus 1, they are now equal, and you can tidy it up. So you end up with an isolated x in the bracket, which is great, and a minus 15 here. Now be careful with this. It's using negative. Sometimes it does, sometimes it doesn't. If it was in the form of x plus a squared plus b, which sometimes it does, for this, a would be minus 4 and b would be minus 15. But because they've already put the minus in here, then a is just going to be 4 and b is going to be 15. So just be really careful with that. So I'm just going to write that down here because it says hence now find the turning point. So we do need to use this to find the turning point. So I'm going to go through a bit more of an explanation now of our graph. So this is what y equals if we're going to draw it on a graph. So to find the turning point of a quadratic, if I do a quick sketch of a quadratic, it's going to look something a little bit like this. And what we're finding for the turning point, that's another way of saying the minimum point. So the minimum point of the graph is this very bottom bit here. So if you think about the y-axis, it's where y is at its absolute lowest. So we need to find the smallest possible number for y. Now this all comes down to the fact that we're having to square a number here. Because if you square any negative number, you're going to get a positive number. So we need to think, well, what is the lowest possible square number we can ever have? So that would be 0 times 0. So what we want to do is to have this bracket equaling 0, because that's the smallest possible square number you're going to get. If x is, say, minus 2, then minus 2 take away 4 is minus 6. Minus 6 times minus 6 is going to be a 36. So you're not going to get a particularly small number for y. So the smallest possible value you can get on this graph is when this bracket here equals 0. And to get that bracket equaling 0, x must be 4. So when x equals 4, this whole bracket will then equal 0. So if this whole bracket here equals 0, 0 squared is 0, so that all disappears. So y must therefore equal minus 15. So the absolute smallest value you can have is when x is 4 and y is minus 15. Okay, this one is joining two different inversely and directly proportional questions together. So you can probably do quite a bit of this already. H is inversely proportional to P, would be that. And P is directly proportional to the square root of T. So the square root of T, so I'm just going to go even again, just square root T. So square root of 196 is 14. If you get stuck in the exam, you're just going to have to go through all your square numbers, starting at 12 squared, because we know 12 squared is 144. And then you're going to have to do, well, what is 13 squared? And that's 169. And then just go through them all. You might have to calculate it. 196, okay? If you learn them off by heart, it makes life a lot easier. So let's go through the first one here. So this is where we're going to have H equaling K divided by P. In order to get K, we need to times these two numbers together, and that's going to get us what the constant K is. So we need to times H by P. So that's going to get us 70. So that means H is going to be 70 over P. Now let's do the direct proportion one. So the direct proportion is going to be P equals something times the square root of T. So this is, what do you times by root T to get P? So what do you times by 14 to get 7? Well, it's halving, isn't it? So you're having to times it by a half. So that must mean k equals a half. So let's use a decimal for this one. So p equals 0.5 of the square root of t. We've got those two formulas. Now what we need to do is write a formula for h in terms of t. What that means is you want to have h equaling, and then on the right hand side only t, so it could be like 3 root t, whatever. It has to have only t's in it, okay? So to do that, we need to combine these two here. Now what we want is a h equals to everything else. So that one's fine, h equals, but we need to turn this p into a t. And that's where we're going to use this equation underneath, because it tells us exactly what p is in terms of t. So what we want to do is to take out that p and just put in what it equals, which is 0.5 root t. So rewrite that out, and we have 70 over, and p equals 0.5 root t. Now we can't leave it like that because we've got a decimal in a fraction. Should be able to work this out though. 70 divided by 0.5. So how many 0.5s fit into 70? Or how many halves go into 70? Dividing by a half is the same as doubling. So we can double 70. So it's 140 over the square root of t. And there we go. Okay, this question here, we've done a little bit of work with functions. So when you're doing the inverse, you're going to use this one here because it's f equals, and then we're just going to rearrange it. So to do that, we're going to have y equals 3x minus 2. You're going to rearrange it to get x on its own. So we're going to add 2, and then we're going to divide it by 3. So y plus 2 all over 3 equals x. To leave your answer, take out the y and put it back to an x. There we go. This next one's a bit tricky. So we want to put g into f